Welcome to our 2013 physics project. This is Colin Wong, Austin Card, and Will Kellogg. Colin, go ahead and explain what we're doing here.
This is mechanical energy, EM. I have three equations, two for potential energy, one for kinetic energy. The first is U, or work. Work is change in energy. U equals mgh, and that's gravitational potential energy. U equals 1/2 kx squared as spring energy, and kinetic energy, U equals 1/2 mv squared. For these variables, m is mass, g is gravity, h is the height. For the spring energy, k is the spring constant with no units. K is the compressed distance of the spring. And for the kinetic energy equation, m is mass, v is velocity in meters per second.
Okay, now here is the problem you guys will be doing. It is a roller coaster problem. So you need to find the mechanical energy at the top, the initial starting point of the roller coaster, the velocity at point 2, and at the top of the roller coaster. Welcome back. Here is Austin Card.
So I'm Austin, and I'm going to show you guys how to do the problem. So for mechanical energy, what you do is you add both your gravitational and your spring constant, since there's a spring right here. So EM is going to equal 1/2 kx squared plus mgh. I'm going to just erase Colin's cloud right here, it's getting in the way. Alright, so we're just going to plug in some numbers here now. So you have 1/2, 100 for your spring constant. It's compressed a total of 10 meters. You're going to square that, plus your mass, which is 250. Gravity, of course, is 9.8. And your height is 50 meters. Does someone want to plug that into the calculator for me? So that's basically how you set up the problem right there. And we'll get back to it once Colin figures out the answer. So here what we want to do is find, we can't do that yet. I apologize for the wait.
Can I pause it?
Which is
Alright, so our answer comes out to be 127,500 joules. So that is your total mechanical energy throughout this whole problem, which we will use for future references at point 2 as well. So what we're trying to do here is, since the height here is 0, all we're looking for is kinetic energy, which is 1/2 mv squared. So we're going to use that equation. Ke equals 1/2 mv squared. Just going to plug in these numbers. So our energy is 127,500, so we plug that in for kinetic energy. Because energy is conserved, so we plug in the 1/2 like usual. Your mass is 250, and we're solving for velocity. This is going to turn out to be And so in the end, your velocity is going to come out to be 31.9374 meters per second. Alright, now here at point 3 we both have potential and kinetic energy, since it does have a height and since it is still moving at this point. So what we're going to do is, your energy is still 127,500 joules since it is conserved. So what you're going to do is just add these two equations together. So you have 127,500 is your total amount of energy. Your mass is still 250. Your velocity is what you're solving for. And your height is 25 meters at this point. Alright, and your velocity, after solving for this, your velocity here is going to come out to be 23.0217 meters per second. Alright, and that is mechanical
And that
energy.
is how you do it. Thank you guys very much.